Dear students, welcome to my channel. Today in this video we are going to discuss about capacitor and its type. So first of all we will discuss about capacitor. So what is capacitor? Capacitor is a device which is used to store charge. The basic purpose of capacitor is to store the charge. Now we will discuss the symbol for capacitor, how you can represent the symbol. So symbol for capacitor is this one. Electrical capacitor you can represent by two parallel lines and these two are connecting line. This is for constant capacitance. If you want to vary the capacitance of a capacitor according to the situation, because in the some circuit diagram we need a variable capacitance. So you can draw the symbol for variable capacitor in this way. Okay, so these two are the symbol for capacitor. So basic purpose of capacitor is to store the charge. So in the next topic we will discuss electrical capacity of a capacitor, and we can say electrical capacitance. This thing we are going to discuss. Electrical capacitance means it is the ability of a capacitor to store the charge. So according to definition of capacitance, electrical capacitance of a conductor is numerically equal to the charge required to raise the potential by unity. Let us understand this thing with the help of the formula. In this case, C is equal to Q by V, where C is the electrical capacitance, Q is the charge on the capacitor plate, and V is the potential across the capacitor plate. So now what is electrical capacitance according to the definition? So the maximum amount of charge which we given to the capacitor so that its potential raised to 1 is known as electrical capacitance. Let us consider we have a capacitor and we connected this capacitor with the battery. So what will happen? Due to this battery terminal, the positive charge will start accumulate here and negative charge will start accumulate here. So because of this, at the plates of capacitor the same capacitance we will develop. So according to electrical capacitance definition, what should be the amount of charge so that its potential raised by 1 volt? That is unity. So finally electrical capacitance of a conductor numerically equal to the charge required to raise the potential by unity. So whatever the amount of charge required to raise the potential by 1 is known as electrical capacitance of a conductor. Now we will discuss the SI unit of capacitor. So SI unit of capacitor is 1 farad. This is the SI unit of capacitor, that is 1 farad. So from this formula C is equal to V from electrical capacitance, we can define 1 farad. So capacitance unit is 1 farad. Farad was a scientist. On his name this unit is farad. It is represented by capital F. And for Q the SI unit is 1 coulomb. And for voltage the SI unit is 1 volt. So now read the definition. 1 farad is the capacitance when a charge of 1 coulomb, required to raise the potential by 1 volt. So that the capacitance of a capacitor is said to be 1 farad when we need a 1 coulomb charge to raise the potential through 1 volt. This is the definition of farad. So after discussing the SI unit of farad, SI unit of a capacitor, that is farad, now we will derive the dimension formula of a capacitor. So now we will derive the dimension formula for capacitor. As we know, C is equal to Q by V. What is Q? Q is the charge, V is the potential. And if you remember, we know this formula, we already derived in earlier classes, V is equal to W by Q, where V is the potential, W is the work done and Q is the charge. So this formula is from the definition of potential. The amount of work done required to bring a charge from infinity to a particular point is known as potential. This is the definition of potential. So whatever the work done we have done to bring a charge from one position to another position, that is your potential difference. So that work done we will write here, and Q is the charge. So directly you can write V is equal to W by Q and substitute the value here. So Q as it is and substitute the value of V. So V is equal to W by Q. So after solving you will get Q by 1 W by Q, and that is equal to Q square by W. So now we have to substitute the dimension formula. So first of all we know Q is equal to IT. This is current and time. So charge is the product of current flow per unit time. So this is your formula. And what is the dimension symbol for current? That is A, and for time that is T. So it means in equation number, this is your equation number 1. So in equation number 1 we can replace Q with AT and W. What is W? W is the work done, and we know the dimension formula of work done is ml square T minus 2. If you remember your 11th standard, in dimensional chapter we derived this formula. Work done is equal to force into displacement, and force is equal to mass into acceleration multiplied by distance. So for m, dimension formula is capital M. A is acceleration, meter per second square. So for meter, again length, and for second, this thing ml. So you will write here T. So we will write here T. For force, mass into acceleration, that is your distance. This is mass for m. Acceleration, meter per second square. So meter is a length, so you will write L. And for time, T per second square means T minus 2. And this is your distance, that is L. So you can add the powers and you will get this thing, ml square T minus 2. So now I am going to substitute the dimension formula of W in equation 1 here. So what is the value of W? That is ml square T minus 2. Now substitute all the values. After substituting all the values, solve it. So you will get m. We have here ml T square. This bracket is required for dimension analysis. So m is negative, m raised to power minus 1. Here L square. So m minus L square, and this one is T square. This thing will not come. We substitute the value ml square. Our W is ml square T minus 2 from here. This is ml square, or you can take from here ml square T minus 2. This is minus 2. So m minus 1, L square is minus 2, and this term will go in numerator, that is T raised to power 4 and A square. So this is the dimension formula for capacitor. So now next we will discuss the type of capacitor. Type of capacitor. We can divide capacitor in two types. First one is based on shape. First type is based on shape. So in this case we have two type of capacitor, that is parallel plate capacitor. You can see the diagram, parallel plate capacitor. So in this case, in the first diagram, there are two parallel plates to each other, and in this case these two plates are rectangular in shape, but in this case these two plates are spherical in shape. So both are parallel plate capacitor, but this one having rectangular slabs or plates, or in this case spherical plates. So both are parallel plate capacitor, and both having the capacitance depends on the area of the plate and the distance between the plates. So each kind of capacitor has different capacitance. So now next we will discuss about this kind of capacitor. This is, all these three are spherical capacitor. Spherical capacitor. So spherical capacitor capacity again depend on the radius of the capacitor, and in this case these two are cylindrical capacitor. Cylindrical capacitor capacity depends on the height and the radius of the cylindrical body. So there are four kind of capacitor. Three kind of capacitor. First one is parallel plate capacitor, second one is spherical capacitor, and third one is cylindrical capacitor. All these capacitors are based on the shape. Now the next type which we are going to discuss, that depends on the dielectric medium. So types of capacitor based on dielectric medium. As we know, what is dielectric? Dielectric are those substances which do not conduct electricity, but when we placed these dielectric substance under the electric field, they get polarized. So now to increase the capacitance of a capacity, we use dielectric medium. So dielectric medium can be mica, it can be any electrolytic substance. Like in your battery cell, electrolytic solution is there, so similar kind of things we can use as a electrolytic substance. And third one is your paper. You can use a copy paper, a page, class book, you are using classmate notebooks, any paper you can use as a insulator, as a capacitor, dielectric medium. That paper is also a dielectric medium. The next one is ceramic. Ceramic is just a kind of a clay which we can use as a capacitor. There is a ceramic pot, so that kind of slab we can use as a dielectric medium. So these four are types of a capacitor based on their medium, dielectric medium. And you know dielectric medium get polarized, and which is used to increase the capacitance of a capacitor. So all these material are used to increase the capacitance. It means it can store more charge. Now next we are going to discuss about what is the purpose and the application of capacitor. So purpose, as we earlier discussed, to store the charge, and the second is to store the energy for small period. Next, application. As we know, in our house appliances there are so many electrical appliances. So in all electrical appliances like your radio, TV, everywhere the capacitor is there. For example, you are changing your channel on your television, on a radio you are moving the knob of radio and you are getting a different channel. So in that case there is a LC, inductor and capacitor tuned circuit is there, which is used to resonance and change the channel. So this concept you will study in the next chapter, in electromagnetic chapter, where you will learn Faraday laws and also that concept I will clear there. So basically capacitor is used in all kind of electrical equipment, in your fan and all. So second point is capacitor can be used as a filter circuit. Like we have a device which is used to convert alternating current into direct current. So for converting AC into DC we use rectifier. So that time there is a mixture of AC and DC current. So when we want to filter the AC voltage, AC current, so that time we use a capacitor. Capacitor used as a bypass filter. It separates the AC from DC. So you will get a pure DC. Dear student, if you like my video, so please don't forget to share and subscribe my channel and video. Thank you.